म्यूचुअल फंड में इन्वेस्ट करने के लिए मैं आपको एक ऐसा तरीका बताने वाला हूं जिसके लिए आपको किसी एजेंट की जरूरत नहीं पड़ेगी। आप सिंपली अपने मोबाइल फोन से म्यूचुअल फंड्स में इन्वेस्ट कर सकते हैं। इसके लिए आपको जरूरत होगी कि एप्लीकेशन की जिसका नाम है गुड आफ्टरनून सर। इस ऐप में खास बात यह है कि इसमें रजिस्ट्रेशन पूरा पेपरलेस है।
Okay, good afternoon, all of you.
जरूरत नहीं पड़ेगी इसमें डायरेक्ट।
Let us start our class
ताकि मैं आप अपने
with previous topics.
नमस्कार दोस्तों, मैं हूं संदीप और आप देख रहे हैं सैनटेक यूट्यूब चैनल। दोस्तों आज की इस वीडियो में मैं बताने वाला हूं कि ग्रो ऐप के अंदर आप कैसे शेयर खरीद और बेच सकते हैं, यानी स्टॉक मार्केट में ट्रेडिंग कैसे कर सकते हैं ग्रो ऐप का इस्तेमाल करके। तो दोस्तों यहाँ पर मैं आपको पूरी प्रोसेस बताऊंगा। वीडियो पसंद आएगी तो एक बार लाइक शेयर जरूर करिएगा। चलिए शुरू करते हैं। तो दोस्तों यहाँ पर सबसे पहले
Okay, good afternoon, all of you. So once again, let us go through our class. So last class we discussed about series and parallel connection of resistances. So basically we have the two types of elements. There is active elements and passive elements. Active elements we are called as a voltage source and current source. Passive elements are the resistor, inductor and capacitor. So let me discuss about the resistor concept. So sometimes in a circuit there is a combination of resistors, capacitors, inductors we are connected according to the requirement to maybe increasing the voltages, currents or maybe reducing the voltage and currents. So for these two functions we are using the resistors. So that is a major concept. Capacitors and inductors also we are using according to the requirement. But majorly the resistor circuit will be plays an important role for designing a circuit. So whatever it may be controlling circuit, regulating circuit, whatever it may be is there. So all cases the resistors will be plays an important role. So that will be decided the voltage as well as the current factors in a circuit. It may be existing circuit or it may be implementing circuit. So last session we discussed about two types of configurations will be there. That is a series connection and a parallel connection. So in case of series connection, so when one end of resistor, so when two more resistors are connected end to end is nothing but the second end of first resistor is connected to first end of second resistor. So if it is follows that type of connection, so that will be we are called as a series connection. So current having only one path. Because of that reason, in the last class we discussed about the current is constant at any instant of time or across any resistor. It may be R1, R2 or R3. The current is same at any instant of location or the time period. So that is about the series connection. So in this diagram we can see here there is a three resistors R1, R2, R3. Just we are assuming R1 having the two ends, 1 dash, R2 has 2 dash, R3 has 3 and 3 dash. Just we are assuming the voltage drop across each resistor is a R1 V1 at R2 V2 at R3 V3. So this is a assumptions we are taking here, and both the three resistors are connected across a voltage source V. So according to the Ohm's law, we know that the voltage is a product of current and resistance. But there is a three voltage drops is there. There is a V1, V2, V3. So that we should be find out. So before going to that concept, already I mentioned about KVL and KCL. There is a Kirchhoff voltage law and Kirchhoff current law. In case of series circuit, we are applying the Kirchhoff voltage law. So that implies the source voltage equals to voltage drops. Here the source voltage is a V is equals to the voltage drops is nothing but it is a summation of V1, V2, V3 is equals to V. So that concept will be we are applied for series connection, right? So first we find out the V1 value, V2 value and V3 value. Already we know the Ohm's law, V is equal to I into R, that is a basic formula. Instead of V, we are selecting as a V1, V2, V3. Instead of R, we are selecting as a R1, R2 and R3. So and the current is constant, that's why as usually we write for three equations. Just we are assuming as a V1 is a equation 1, V2 equation 2, V3 equation 3. So according to the Kirchhoff voltage law, the sum of individual voltage drop equals to source voltage is nothing but V is equal to V1, V2 plus V3. So we are substituting the values of V and V1, V2, V3. So then we are getting the equation like as IR1 plus IR2 plus IR3. I we are taking as a common. So then we are getting the value as R1 plus R2 plus R3. That is equals to V. So if you substitute the V value instead of I into V value instead of source voltage I into R, that can be we can write, or simply I will be we are moving to the LHS side. So I is the right hand side, so we are moving to left hand side. So then the equation becomes V by I is equals to R1 plus R2 plus R3. So we know that V by I is equals to, that is equal to R. So according to the Ohm's law, R is equal to V by I is the formula. But here R is the total resistance of R1, R2, R3 is nothing but the three resistors summation is equals to R total. So generally resistance is represented with capital R, but it is not the single resistance. It is a summation of three resistances. Because of that reason, so here we are mentioned as a R total, R suffix capital T if you are right, that is represent the total resistance of the circuit. So that implies R1 plus R2 plus R3. This is a basic formula we are used when number of resistors connected in series. Similarly, if there is n number of resistors is present in series circuit, then the equation is becomes RT is equals to R1 plus R2 plus up to so on Rn. So that is a formula we are used for series connection when number of resistors connected in series. Next we go through the parallel connection. Parallel connection also we are called as a shunt connection. So in case of shunt connection or parallel connection, all similar ends are connected to a common point. All similar ends we are connected to the another point. Means first ends are connected to one point, second ends are connected to another point. So this is a phenomena we are followed for parallel connection. So there are three resistors is there, R1, R2, R3. They are arranged in parallel, and we are assuming the current is flowing through that individual resistances are I1, I2, I3, and they are connected to the voltage source V. So in case of parallel connection, the current is divided into several parts according to the resistances. If two resistances present, only two currents will be appears here. If there is three currents will be there. If 4, 5, 6, so up to the number. So according to the number, the currents will be divided. So but the voltage is always constant. It does not changes. In case of parallel connection, the voltage is constant. We can measure at any resistance. The V is the same. So if you are applying Kirchhoff current law, according to the Kirchhoff current law, the total current in circuit is equals to sum of the individual currents. So I is equals to, we can write as a I1 plus I2 plus I3. So first we find out the I1 value, I2 value and I3 value. According to the Ohm's law, we know that I is equal to V by R. That is a basic formula. So instead of that, we can assuming as a I1, I2, I3. Instead of resistances, we are assuming as a R1, R2, R3. So where V1, V2, V3 is not present because the voltage is the equals, is nothing but V is equal to V1 is equal to V2 is equal to V3. Means three voltages are the same. Because of that reason, instead of V1, V2, V3, directly we can writing as a V value. So next, if you are substituting I1, I2, I3 values in this equation, so I is equal to V by R, that is we know. Instead of R, we can write as a R total. V by RT is equals to V1 by R, V by R1 plus V by R2 plus V by R3. We are taking as a common. So then we getting the equation as V of 1 by R1 plus 1 by R2 plus 1 by R3. Both sides we get cancelled. So then we are getting the formula as 1 by RT is equals to 1 by R1 plus 1 by R2 plus 1 by R3. if there is n resistors is present, then the equation is becomes 1 by RT is equals to 1 by R1 plus 1 by R2 plus 1 by R3 up to so on 1 by Rn. This is a formula we are used for calculating the resistors when they are connected in parallel. For series connection, this is a formula we are used. This in parallel connection, it is the formula we are used. So sometimes there is a combination resistors will be present. It may be series connection and parallel connection. So you can see here in this diagram, there are 5 resistors are present. There are 5 resistors are present. So you can see here R1 and R2 are connected in parallel. R3 is connected in series because there is no additional resistance is connected across the R3 resistor. Because of that reason, we are assuming that is a series connection. Next, R5, R4 are connected in parallel. So here there are 2 parallel connection, 1 series connection. So in these cases, to find out the total resistance, because if any number of resistors is given in a circuit, we simplify into a single resistance. Then only we can possible to determine the voltage value or current value, whatever it may be asked in the examination. So that is our destination. So for example, if the model is like this, it is having the 5 resistances, 2 pairs of parallel resistance will be connected here. First we simplify the parallel connection. So whatever the circuit is given, first we simplify the parallel connection. Then only we go through the series connection. So first we we indicating the nodes as A, B, C and D. So in the circuit is not given the exactly nodes. So but just we are assuming there is a node A and B, R1 and R2 resistors are connected. In between node B and C, R3 resistor are connected. In between node C and D, R4 and R5 resistors are connected in parallel. So first we simplify the parallel connections. So how can we simplify parallel connections? So already we know the formula 1 by R equivalent is equals to 1 by R1 plus 1 by R2. So that is a formula we are using. So ఇక్కడ R total place లో instead of 40 we can write as a AB because the resistance is in between the node A and B. Because of that reason we can write as a 1 by RAB is equals to 1 by R1 plus 1 by R2. That implies, so if you want to simplify this equation, so what you are getting here, first we take the LCM R1 R2. So that R1 next in numerator we are getting the value as, so in case of R1 the numerator will be R2, in case of R2 the numerator R1. So if you are arranging in a proper order, so what we are getting in numerator R1 plus R2 by R1 R2. But it is a value of 1 by R equivalent or RAB. But what is our value? R equivalent value, just we are interchanging the positions of numerator and denominator. Means 1 is come to denominator, RAB comes to the numerator. So similarly in RHS side, R1 R2 comes to numerator, R1 plus R2 come to in the denominator. So then the equivalent resistance R1 R2 by R1 plus R2. Last class also I explained about when 2 resistors are connected in parallel, what is the formula we are using when connected in parallel, what are the formula we are using. So those things also we are discussed. Right? So first we find out the RAB. Then R3 is a series. There is no need to find out the series equivalent resistance. So next we have the another parallel connection between the C and D. That is the R4 and R5. So the same formula we are used here. 1 by RCD is equals to 1 by R4 plus 1 by R5. So first we take the LCM and we are interchanging the positions of numerator and denominator. So directly we can write the formula as RCD is equals to R4 R5 by R4 plus R5. So that is the equivalent resistance between the C and D. So if you redraw the circuit, so then we are getting like this. So in between A and B, RAB resistance. In between B and C, R3 resistor. In between C and D, RCD, that is the equivalent resistance will be present here. So therefore, the total resistance in a circuit we can determine as a R is equals to RAB plus R3 plus RCD. Instead of RAB, we can write as a R1 R2 by R1 plus R2. Instead of RCD, we can write as a R4 R5 by R4 plus R5. So this is a method we are followed for calculating the series and parallel connections in a given circuit. So first we see one example so we can easily understand the combinations of parallel connection. So before going to that, first we discuss about the series connection. So then we discuss about parallel connection. Finally we go through the combination of series and parallel connection. So what is we study in case of series connection? When number of resistors connected in a series, we can find out an equivalent resistance and we redraw the circuit into a single voltage source connected across the resistance value. So that is the method we are followed here. Right. So you can see here there are find the voltage across the three resistances shown in a figure. So always we understand the proper concept of question. So he asked about the voltage or individual voltages, right? Find the voltage across the three resistances shown in a figure. So he given a diagram that is a R1, R2, R3 resistors is present and they are connected across a 60 volts source. 60 volts source. So the current is same. We don't know the current value. But the resistance values is given 10 ohms, 20 ohms and 30 ohms. These are the resistance values. Right? So first we find out first we write the given data. What is given? Given that V is equals to 60 volts. Next is given the values of R1, R2, R3. So we write as R1 as 10 ohms, R2 as 20 ohms, R3 as 30 ohms. Then after, to determine the individual voltages drops. So whatever we are using in the series connection. So you can see here, what is we write here? V1 is equal to I into R1, V2 is equal to I into R2, V3 is equal to I into R3. So these formulas will be, we are used to determine the individual voltage drop across the resistors, right? So here we discuss about those things. So first to find out the VR1, VR2, VR3, so there is a I will be needed because R1, R2, R3 values is given in the problem, but is not given the current value. So because of that reason, first we determine the current value. So if you are applying the Ohm's law, we know that I is equal to V by R. But R is the total resistance of the R1, R2 and R3. So first we see about how they are connected. So both the three are connected in series. Already we know the formula. R equivalent is equals to R1 plus R2